Okay, we're going to go over some problems from page 21, the practice quiz for shape, polarity, IMF, Lewis dot structures. So we're going to start out with some Lewis dot structures. And remember, our steps for drawing a Lewis dot structure is step 1, count up your valence electrons. So my nitrogen, let me get my pen going. Okay, nitrogen has 5 valence electrons, oxygen has 6, hydrogen has 1. So we add that up all together and we get 12. Step number 2, you put your least electronegative element that is not hydrogen in the middle. So nitrogen is my least electronegative element. I'm going to put it in the middle. It is further away from fluorine than oxygen is. And then I'm going to connect them with single bonds. Step 3 is you're going to give your outer atoms an octet. So hydrogen doesn't want an octet, it only gets 2 electrons, so it is good. So I'm going to give oxygen an octet. Step 4 is I'm going to put all of my leftover electrons on the central atom. So I got to stop and count at this point. So I've used up 2, 4, 6, 8, 10 electrons. I've only got 2 left. So I'm going to put these 2 on nitrogen. And then my last step is I'm going to check to see if everyone has an octet. And it looks like they do not. So what that means is I need to form a double bond. So I'm going to take one of my electron pairs from oxygen, and I'm going to have oxygen share those electrons with nitrogen. So now I still have 12 electrons. So I've got 2, 4, 6, 8, 10, 12. But now everyone has an octet and is happy. So that is number 1. Let's look at problem number 2 here. Again, the first step is going to be count up my electrons. So selenium and oxygen, they're in the same column. They all have 6 valence electrons. So 6 times 3, I'm going to have 18 electrons in my picture. I'm going to put the least electronegative element in the middle. That's going to be the one furthest away from fluorine, so that is selenium. And I'm going to attach the other atoms to it with a single bond. Next step is I'm going to give my outer elements an octet. And then I'm going to put my leftover electrons on the central atom. So I got to stop and figure out how many leftover I have. I've used up 2, 4, 6, 8, 10, 12, 14, 16. So I only have 2 left over. So 18 minus 16, I got 2 leftovers. I'm going to put them on the selenium. My last step is I'm going to check to see if everyone has an octet. And once again, they do not. So I need to put a double bond. But look, I actually have 2 places I could put a double bond, on the left and on the right. And they're both equally good places for a double bond. So that is the clue that this is actually a resonance structure. So I'm going to have to draw both possibilities. So I'm going to show the double bond on the right, and I'm also going to show the double bond on the left. And this is important because the true structure of selenium dioxide is somewhere in between these 2 realities. So both bonds are going to be equal in length, and they are going to behave as if they are 1.5 bonds. So they're going to be, like, if you look at the bond length, bond energy, it's going to be somewhere in between a single bond and a double bond. All right, let's go down here and look at NHF2. So step 1 is add up the electrons. So that's 5 plus 1 plus 14. So that adds up to 20. I'm going to put my least electronegative element in the middle. That's nitrogen. And then I'm going to put fluorine out here, give my outer ones an octet, put my leftovers on the middle, and I'm good. So 2, 4, 6, 8, 10, 12, 14. Whoops, one of these is actually supposed to be a fluorine. Okay, that's what went wrong there. All right, and then I'm good here.